that we went, or rather that we did last week in class. I'm not gonna go over in super detail, but I will just go over the major things that we have changed and the major additions that we did. As for the little stuff, I'm just really not gonna go over it. I just hope you did pay attention during class and that you look through the class notepad on Google Drive to see if anybody took notes about anything that you may have missed. Um, Pretty much, I'm going to go over the game objects that we added in order to have functionality. So, again, let's play the game. So all the functionality that I'm going to go over right now, again, is just the movement of the enemy, which is called the enemy AI. So the enemy should now move, and then we change the obstacle script. Obstacle script by copy pasting your old obstacle code into a new script, and then creating another new script that will check for damage, so that when you collide with the enemy, you can get hurt. So that's pretty much what we did. And then we created a game object that checks to see if we have stomped on the enemy so that we can make it disappear and pretty much kill it. Oops. Died. Let's see. Oh, so the game object that is, there we go. The game object that is the stomper is the one that, oh well, actually it's two. The stomper and like the stomp box, they're the ones that will be reading those functions. But as you can see, you really have to land on top of the enemy, like right above his head, or else he can't make it disappear. And yeah. So let's look through all those game objects. So your enemies should all have, regardless of whether you have a slime or not, your enemies now should have a stomp collider attached to them. And the stomp collider game object is gonna have a tag, a stomp box, and a layer of enemy. So if you don't have that, you just click on the drop down menu and add it. You check here in this plus sign, and then you put in the name, you save it, and then you go back to the game object, and then you select the new tag that you created. So yeah, make sure that those the tag and the layers are correct. You're gonna have a stomp script on this, and I'll go over all this stuff again in a little bit. You're gonna add an audio source component, and you're gonna add a box collider 2D component that is a trigger. So that's all you need for the stomp collider. Now for the for the custom alien, I added a stomper collider, and this collider is going to have a tag of stomper and the layer of player. And then I just added a box collider 2D, and we just need the collider. We do not need it to be a trigger. So just make sure that trigger is unchecked. And then the other two things that I added to the scene are a checkpoint game object. This game object is empty. As you can see, it doesn't have any component at all except for the transform. And I added a tag to it called checkpoint. The layer is default. And then I just added an icon to it by clicking here so that I can see it in the scene. And the checkpoint is your respawn point. So now we're going to have the functionality that if your player comes off a platform, they will get respawned to that checkpoint. And then the last game object is the fall collider, which detects whether you have fallen off a platform or not so that it can respawn you. And that has a tag of fall collider and the layer default, and it's a box collider 2D that is a trigger. So those are all the game objects that we added to this scene. I also made some changes to the health system scripts, which I will go over really briefly. And we had to make some changes to the custom character controller to add functionality for like falling, for respawning, and to talk to the. I don't think we need to talk to the enemy within this script. I think I'm using another script, but I'll go over the changes that we made there too. So let me just talk about that health system script first. So before, if you had an error that said something like array out of range, index out of range, it was because the array that we're using to change the hearts in your health system over here was public. That meant that the number could have exceeded the array that you had. So arrays always start from 0 onwards. And the problem that I was getting was that the array was reading -1 for some reason. So in order to prevent that from happening, we had to make the array private instead of public, so that the numbers are always going to be constrained from 0 to whatever number ends in the array. In our case, it was 4. So we're just binding that array between 0 and 4 privately, so that the game or the editor cannot access any other name outside of that, any other number outside of that, so that we don't have issues. So let me open that health system script. This is one of those things, again, like I said before, that I'm not going to go over in super detail. I'm just going to explain the general idea of what I did, because it was fairly straightforward. Okay. Here we go. So make sure that Unity Standard Assets, using Unity Standard Assets 2D, is either deleted or commented out, because we're no longer going to use it. And this is the line that you had before here, private sprite, heart sprites. That's why I had to comment out. And then instead of it being a private sprite, I had to just create a public array literally by calling every sprite in the array. And that's what I added. These are just public sprites that in editor, because they are public, you'll be able to allocate the pictures to each slot like you did before. So once we edit the script, you have to like re-add these images again, because they're all going to be empty. The last thing that we did, make sure that your player now is your custom character controller, like we did here. Before, it was the 2D character controller. And in update, we just added these conditionals right here. And we're just literally saying, if the health equals to 3, change it to the image 3. If the health equals to 2, change it to 2. So it's pretty straightforward. And that's all I did for the health system. Now, let's see what I would like to go over next. So let's go straight into the enemy script. So this is gonna be it. We created a C# script called enemy, and that's what I'm gonna be looking at right now. This script is all functionality to make your enemy move. And it just does some math, and it also looks at physics 2D. And then it checks some booleans to make sure that we are within the checks that we want to be at. Oh yeah, so just make sure you have all these using backlog code stuff. And then the variables that I had are a public layer mask called enemy mask. That's why we can use the, over here when I had said do layer enemy, that's why we're setting on enemy layer mask. So that's that. Then a public full speed, obviously we want the enemy to move, so I'm just setting it equal to 1F. And we're accessing its rigid body 2D, its transform, which is its coordinates, and we're calling it my position. And then we're getting 2 floats here for the width of the sprite and the height of the sprite, which is the length of the sprite. now let's go back. So the way that I was able to do this was by by adding these components, obviously, to the enemy that you already had. So I told everyone to go back to an older scene and just um, make a prefab out of an enemy, so that it was in a prefabs folder. And then we just brought these enemies into the scene and added a few things to them. We added the rigid body 2D, which is the main thing. Everything else was the same as it was before. So yes, you should have a rigid body 2D component attached that is frozen on the Y and the Z, because the enemy is only going to be moving on the X axis. Alright. In start, we're just finding a sprite render component, and we're just making sure that we're allocating it because we need to change it. And that should be here. Here's the sprite render component. And here we're just setting some variables that we just created. We're setting them to different things. So my position is going to be this dot transform. This just literally means this specific game object. Since this entire script is going to be attached to the enemy game object, we can actually tell the code to look directly at this specific game object's component. In this case, we're assigning my position to the game object's transform coordinates. We're assigning the my body variable to the game object's rigid body 2D components. And then my width and my height, we are going into my sprite, which we had set up here. Sprite render equals my sprite. So we're saying, look at your sprite render, check the bounds that extend on the x-axis to check the width, and the y to check the height. And we're going to use the width and the height of the sprite in order to check for whether it's grounded and blocked or not. I'm sorry, no, we're not. We're going to do, sorry about that. We are checking the width and the height of the sprite in order to draw these lines in fix update. So I will go over that right now. So in a fixed update, not in a regular update, you're going to write all this code. I know it seems a bit complicated here, but it's actually really simple stuff that's going to be happening visually. We're creating a two-dimensional, not two-dimensional, but we're creating a line on the X and Y axes. And we're setting all this math to it, which literally just means a line. And then this debug draw allows us to see that line that we just created with the code above. And I'm using this first line that we draw in order to check whether the enemy is going to be grounded or not. Which is why I have this boolean here called isGrounded. We're casting a physics 2D line cast, which allows us to see the line and so that we can detect whatever constraints we're going to be adding, which are going to be down here. The second line that we are going to draw is going to be to check if there's a platform or something blocking us from, not us, blocking the enemy from moving left and right. That's why here in this vector 2, we are setting the line to be vector up. Is it? Yeah. Vector up, and because that will create the line vertically like this. And then here vector down is going to be casted down. So it is a vertical line, but it's going to be casted downwards. This one over here is going to be a small line. And I say small because we added these floats to it, which will make that line much smaller than the one that we just created above here. But this line, it's going to be casted coming out from the right of the sprite. And I will show you that right now, these lines of code, because you actually can see it visually. So let me zoom in. You can only see a debug.draw line in the scene mode, you can never see it in the game mode. So I'm just going to zoom in all the way here and then hit play and then hit pause really quick. Okay, so those lines of code that I just went over is this long vertical line right here, and then this really tiny one. So this tiny one checks if we're going to be blocked or not, and this long one is going to check whether the enemy is grounded or not. So you have to make sure that the line extends past your box collider on the enemy. So you see mine right here, I have this much left. So make sure that you do have quite a bit of space down here, or else your enemy is just gonna fidget around, like going back and forth, back and forth, back and forth. Like the animations are just gonna think that there's something wrong with it not being grounded. So in order to fix those issues, just make sure that this line extends way further than the actual enemies being on the ground. And the way that you can change this line, it depends on your game, honestly. Some students changed this with a positive number, and some of them changed it with a negative number. So just debug that. But what you're going to want to change is this right here, my height. So instead of putting the variable which we had written up above, it's a float, my height. So you can actually just take the entire variable and put in a float yourself. So try -1 f, or try 0.5 f, just to start, to gauge how far that line ends up being away from your enemy. That's what I recommend in order to fix issues like that. So yeah, all that bit of code, which seems a lot, the only thing that it does is create these two little lines right here. Another thing that I completely forgot to mention was that for that Stomp Collider game object that I had to create, you want it to be right above the enemy's head, and you don't want it to be really big. You can definitely extend it longer than mine. As you can see, mine's literally just this little chunk. You can make it so that it covers the whole span of the actual sprite right when you jump on it. That would make more sense if you did it longer like this instead of shorter, like right above his head. So yeah, check the sizing of your Stomp Collider game object, and also the size of the box collider on the actual enemy. This box collider should be further away from the Stomp Collider. As you can see right here, I have a gap. But it should definitely span the length of the enemy's sprite. It's okay if it extends a little bit further down like mine does. It's not an issue, as long as you have this little gap right here. Yes. So that's what I wanted to show there. And then the last little bit of code here is to check if the enemy is grounded or if it's blocked. And we're just doing a conditional statement. Exclamation mark is not grounded, and then these two little bars is or is blocked. So if the enemy is not grounded or if it's blocked, we are going to make the entire game object rotate 180 degrees. That's what this means. So we're looking at the vector 3, like I said before, that is a coordinate of x, y, z. And in order to rotate something, we're actually doing it on the z-axis, and that's a 3D game object coordinate. So that's why we're using a vector 3. We're calling it currot for current rotation, and it equals the position dot Euler angles. And Euler angles is just a built-in class that allows us to look for rotations. And then we're just setting the rotation on the y. Oh, sorry, we're not setting the rotation on the z, we're setting it on the y. That makes sense. And we're just adding it 180 degrees to it, and not the z. Sorry about that. And then my position that Euler angles is going to be the current rotation. So the rotation is going to be the current rotation, which is 180. And then over here, we're just adding force, or rather velocity, to the enemy so that it actually moves. And it's just going to check on the vector 2, its velocity. We're going to set it to the rigid body's velocity. And we're checking it on the x-axis, obviously, because we just want it to move on the x. And then we are multiplying times negative speed. The reason why we're doing negative speed is because these enemies are going to start walking left instead of right. That's why it's negative. And then we're just going to set the rigid body's velocity to my velocity, which is the rigid body's velocity. So we're just setting everything equal to each other. And that's pretty much it for the enemy script. Now, the other script that the enemy needs is this obstacle script, not the old obstacle script. So you can check by checking here the void. The old obstacle script, which we're going to be putting on like spikes and stuff like that, is going to have on trigger enter. But the obstacle script for the enemy that it gives us damage is going to be on collision enter. So that's how you can tell the difference between the two. And it's really easy. We're giving the script access to the custom character controller script, and we're calling that player. And in start, we're making sure that we're setting the player to be the script with the tag player. And then we're just doing a void on collision enter 2D, collision 2D col, not collider 2D, collision 2D. And then we're checking it with an if conditional. If we're colliding with a game object equals to the player, then the player is going to get hurt, it's going to get damaged, and it's going to have to start coroutine. If it's not damaged, then obviously the hurt is going to be false. And then over here, we have on collision exit 2D, collision 2D col. We're going to check if if we're coming out of the collision, we're going to check if it's player, and if it's coming out as false. So pretty much we're doing a double check when we're not inside the collision of the enemy. We're just making sure that the player cannot get hurt. It's just like a double check. And this script, as well as the enemy script, again, should both be attached to the enemy. You can see that here on mine. I'm going to stop this video here and then talk about the other stuff.